Hi, I'm Bob Bowcock. For over 40 years, I have worked with community drinking water systems throughout our nation as a licensed water treatment and distribution system professional. Community drinking water systems pose a significant risk to indoor environmental quality. Community drinking water systems are a complex network of water sources, treatment facilities, storage, transmission, infrastructure, and distribution system matrices. Sources of water may vary by type: lakes, rivers, springs, or groundwater, each representing complex quality. Surface water systems, lakes, and rivers are often contaminated by natural organic material, while groundwater, springs, and wells are contaminated by naturally occurring inorganic material. All water is subject to pollution, man-made compounds like fuels, pesticides, and fertilizers. All water sources are subject to microbial contamination like fecal coliform, Legionella, Cryptosporidium, and Giardia. All three water contamination categories can be reduced to safer levels: seasonal changes in water quality, blends of various water qualities, treatment system failures, aging infrastructure, design flaws leading to excessive water age, all expose building occupants to unnecessary manageable risks. Building and facility operators must develop and maintain a detailed understanding of their local water quality, how the quality changes, and base building operations on water quality challenges. What are your sources of water, day by day, hour by hour? What is the disinfectant used, and what is the residual at your facility's location in the distribution system? Free chlorine is mostly used in low organic groundwater, while most surface water systems use chloramine. Chloramine sequesters chemical reactions between chlorine and naturally occurring organics that form toxic disinfection byproducts, like chloroform, trihalomethanes, and haloacetic acids. If you smell chlorine odor in drinking water, it is mostly airborne toxic byproduct compounds that can contaminate indoor air. Chloramine is not a fix for drinking water disinfection. In fact, it presents more problems than solutions. Chloramine is the combination of chlorine and ammonia. When chlorine combines with ammonia, it is no longer free to combine with the naturally occurring organics and form regulated disinfection byproducts. When the US EPA changed the regulations governing disinfection byproducts, many utilities simply turned to chloramine rather than treating the drinking water to remove the organics. Natural organics can be summed up pretty much as dirt left in water. Organic matter, the basic food source for biofilm, grow in our drinking water systems. Most biofilm is harmless and is found everywhere there is water or moisture. Biofilm, however, when allowed to multiply, become the housing and food source for dangerous bacteria and microbes to grow and thrive. Disinfectant is used to control biofilm growth and microbes. Maintaining a disinfectant residual presents many challenges for community drinking water systems. Understanding disinfectant demand, which changes based on weather conditions, how the water is treated, what chemicals are used, where the water is stored, and for how long, and finally, just how far your facility is down that long and winding pipeline. Chlorine is consumed by demand and age, leaving no residual protection. Chloramine, though longer lasting, is less reactive, causing corrosion, and breaks down to free ammonia and dangerous nitrification conditions. Nitrification is a microbial process by which reduced nitrogen compounds, primarily ammonia, are sequentially oxidized to nitrate and nitrite. The microbial process allows Legionella and other dangerous microbes to thrive. Any system disruption from the treatment plant to the tap inside your building will dislodge these microbial colonies, exposing occupants to aerosolized bacteria. Sharing these brief moments with you, I cannot overemphasize the importance of truly understanding where your indoor environment obtains its water and how you can plan to mitigate for dangerous conditions.